Okay, so it's being recorded now. So we were saying that stateless, when you say stateless, it doesn't refer to only the knuckles, right? The, what it means is that the server doesn't keep track of the state, right? So the state is not tracked by, right? So
Does it does it not mean that you have to uh, be I'm going to use the word approve, but that's the wrong word. Um, approve every time you want to inbound or outbound when you're stateless, right?
yeah, but it's not only about security groups or knuckles. Stateless means that the server doesn't keep track of the state. Okay, it doesn't keep track of the state.
But is
Your
it only related to a server? Could it be related to a state of an action where it needs to approve you um,
it
on
has to
both sides of the question?
it has to be with it has to do with the server because the server it all starts from the server. The server doesn't keep track of any response or request. It's just stateless. When there's an application, there's a server somewhere, either EC2 instance or Lambda. But behind Lambda, there's a server. There's always a server, right? So the server doesn't know where the request is coming from. It is responding, but it doesn't know what's coming from. As long as it comes with all the credentials and all the things that it authentication and everything, it just responds. It doesn't know what is coming from. So that's what stateless means. In the case of the security groups and knuckles and all that, the state means when you enter the EC2 instance, if it is a security group, you just go out. And because it keeps track of the state. It's stateful.
That's stateful, right? That
Yeah.
is called stateful.
Yes, that's stateful. You go in and come out because it's keeping track of your
Mm-hmm.
state. So in this case, an application is stateless because there's no concern about the state. That doesn't matter. Remember, when you create,
Oh, so it doesn't reauthorize you when you're trying to
it,
do something else. So it authorizes you to access the server, and you have to be reauthorized to pull something out, for
but
example.
but that's security. That's security. But this is not security. This is just keep track of the state. For security, that's something else. Like I said, state doesn't refer only to security.
This is a concept that, yeah, I've looked into stateless and stateful, and there's so many definitions from different people.
Yeah, yeah, that is right. That is right. The other day, I remember that Oscar asked me, Professor, what services are stateless? And I said, Oscar, I've been reading about that a lot. And there's so many opinions that sometimes you don't even know what the right answer is, right? But
Me, if you the way that I understood from everything that I read, if you need be authorized to access something and reauthorize to come back out, that means you're stateless because it doesn't keep track of who you are. It doesn't keep track of your state, basically.
yeah, but that's from the security standpoint.
If it's
When it's
stateful,
when
yeah.
it's when a server doesn't know where the request is coming from or doesn't care, that's stateless too.
Interesting.
Yeah. For example, RESTful APIs. Have you guys heard about that? RESTful APIs.
Yep.
It's stateless because the server doesn't care where the request is coming from, as long as the content type, the credentials, the method, the HTTP method, even if it is a post or a get or whatever, as long as they are in the header of the request, the server doesn't care where the request is coming from. That means stateless. Okay.
For me, my understanding, only one service is stateful, that is security groups. Rest everything is stateless.
Okay, that's from the security standpoint.
Right,
That's for security groups and NACLs. But
right.
status doesn't is not limited to that only.
No, then other things on applications and everything
Yeah.
is stateless.
When you use auto scaling,
Hmm.
your applications are stateless. Why?
Yes,
Because they are disposable.
right.
What happens when you have to scale in? Do you care about the state? We
No.
just remove the EC2 instance and that's it,
Yeah.
right? Because all of them are the same. So the solution is move the state of your server into a key value store. What is the key value store? What is the key value store that we know?
It is in S3,
It's right here.
Elasticache.
Elastic Cache, remember? It's an in-memory key value store, right? Or DynamoDB. Don't forget that DynamoDB uses JSON, which is a key value pair. Okay?
Hmm.
So what are we doing? You want it to be stateless. What do? You move the state of your server, right? And you store it in a key value store, right? Now, you can have a stateful application as well that keeps track of the state, but you want it to be stateless, right? So that you can scale up, scale down, scaling, scale out. That's the easiest way to do it, making it stateless, right? So you don't have to keep track of the state and worry about that. Right? That's why RESTful applications, RESTful APIs are becoming very, very popular nowadays because they're stateless, right? So the process, it lets you use the scale out pattern without having to worry about inheritance or loss of the state information. As it is stateless, you don't lose the state information. You know, what is keeping how you can keep the state is, for example, when the person logs in, and then you keep the state of the person. You keep the session open, right? You keep a session open, and then you every time the person moves from one page to the other, you still keep that state. You know who the person is. So have you noticed sometimes when you log in, you see welcome, for example, Anand in the right hand side top, right? You see welcome Anand. And then when you move
Yes.
from one URL to the other one page to the other one, still you see welcome Anand there or Anand, right? Because it's keeping through a token or an ID. The ID is keeping you on a session that is open until you log out, right? So it's keeping the state, your state. It's you, right?
Hmm.
So the implementation, what you have to do, use Amazon Elastic Cache, that's key value store, or DynamoDB for data storage, right? Prepare a data store for storing the state information, right? Use as a key in the data store an ID that identifies the user, a session ID or a user ID, and store the user information as a value. So what is the user information? The ID, first name, last name, the token, if there's a token, a JSON web token, your information, right? This is very commonly seen when you have a third-party login, like a federation login with Google or Facebook, that they provide a token, and there's a session ID. There's an ID for that particular person only. Okay, that will die when the person logs out, right? In the case of Google, there's the ID is always the same because it comes with your Google account, your Google email, right? So when you log in again, it's gonna be the same ID again. It's not gonna be different, right? But it's very secure, right? Just in case someone gets that ID, they get your information from your Gmail, right? But it's very secure. That's why people use it as a login option. So you store, reference, and update the state information in the data store. That is the DynamoDB. Instead of storing it in a web app server, right? Never store your credentials or state information in a web server. Not secure, right? It's not secure. Remember that a web server is um, most of the time exposed to the internet, right? And an app server may or may not be, depending on your architecture. So we have an elastic load balancer here. We have the three EC2 instances. You have the auto scaling here. That's why we treat these guys as stateless, right? And then the state information, which is the ID, the session ID, everything related to that user, we're going to store it here in the key value store, either Elastic Cache, if it is an RDS, or if it is DynamoDB. Right? Schedule scale out. The problem is an application traffic does not scale originally or organically, but has huge jumps at specific periods of the day or for an event. We know this already, guys. You know that an application by itself will not scale, right? So you have to create auto scaling and scaling by schedule or scaling by policy, right? By policy is if the CPU is higher than 80%, for example, and by schedule you want to scale, for example, in the morning at 9 a.m., you want to scale out, and then you want to scale in at 5 p.m. because your instances are not being used after 5 p.m., for example, right? So one of the advantages is scaling advance of a traffic spike will occur. Let's say that your traffic spike is between 8 a.m. or 9 a.m. and 5 p.m. So you have a schedule policy and then you scale, in this case, scale in, but you can scale out, whatever, depending on your policy. So I'll ask the load balancer here, communicates with the EC2 instance, then it will increase the number because auto scaling has a schedule scale out. Sorry. And of course, there's an AMI here that is taken in the launch configuration, right? Remember, don't forget two steps. Two steps when you create an auto scaling group. The first step is launch configuration,
Mhm.
and then you create the auto scaling group. Okay? So the implementation, you create a customized AMI, right? Create a launch configuration for your auto scaling group. When it says customized AMI, what it refers to is that it has some software um, installation there, some updates that they're gonna be every time you run your EC2 instance, it may update your AMI, right? New instance. You create a scaling group for your instances behind the last load balancer options. You can create a schedule update to launch or terminate instances at a specific time, or create a scale by recurrence policy that will automatically scale your instances based upon cron. Cron, remember we did it. I think I did it. I don't think I did it in a video. I think it was at the end of one of our classes that I believe that only two or three people stay on and the other left because it was the end of the class. But I remember that I schedule, see here. I think, let me see here. I think it was, let me see. It was one of these videos that I created a cron job. I created a cron job, right? A cron job that you do in using um, CloudWatch. And then here you go to what it says rules and then create a rule. And then here you can use schedule and then use a cron job that sets the EC2 instance to be stopped using a lambda function here, for example, a lambda function here at a specific time of the day, specific day of the week, specific week of the year, month of the year. So I created two rules here. Let me see. Go back here. Rules. I have one rule here that starts my EC2 instances every day at 10:36 GMT, which is 4 p.m. Eastern Standard Time. Is 4:36 p.m. Right? So that's gonna be a 4. Of course, remember that GMT has 4 hours ahead. So 20 is gonna be 16 here. It's gonna be 4:36 every day and every month, every day of the week, every year. So like that. Okay. The star is a universal wildcard that means everything. Okay. So if you go here and we say cron job, AWS, so it's gonna tell you, for example, let me see if it shows here. One moment. Uh, mm, okay. It's a cron expression, AWS. It's right here. So the first one is minutes. This one here. Minutes, hour, day of the month, every day of the month, month, every month of the year, week, we use this guy, the question mark, when it's every day of the week, every day of the week, and this is the year, every year. Okay, so right now I don't have an instance because I deleted it, but I created a lambda function that stops and starts the EC2 instance. For example, this one stop my EC2 instance. I create a lambda function here that first stops the EC2 instance, right? And then sends a message to Slack saying that the instance was stopped. Okay? And then the other one, it does the same. The only difference is that instead of stopping the instance, it starts the instance right here. Right? And this is in Python. And then it sends a message to Slack. Right? So that's a cron job. Okay. Maybe later I can create an EC2 instance, change the ID here, right? The instance ID here, and then stop it for you guys to see it, and we see the message sent to Slack, right? So that's a good way to notify administrator through Slack that the EC2 instance was stopped at 5 p.m. for example, and the next day is started at 9 a.m. It's a good way to notify people. Right? So the job observer pattern, the problem is you need to manage resources against the depth of your work queue, right?
Before you start on this one, I have a question on your the previous one, the state sharing.
Yes.
why would you want to make the application stateless if you want to keep track of the state of the application to make sure that it's the server is running, or if
You
you have any problems?
you can
Why
keep the
move it
track of
away? Why move it away? Huh?
you can keep the track of the state, but not in the server. You can keep it in the store right here, which is more secure. You still keep the state, but you don't keep it in the servers.
What is this going to do? What is this going to help save or um, help with the execution of this application, right?
It's just for
Whether
security.
it's stateless or not.
It's for security purposes, right? It's, you have the session ID or the user ID. Why would you keep that in the server?
But that's why, if it's for security purposes, isn't that what the purpose of the security groups and
No. The security group is just to leave access to the server.
uh-huh.
That has nothing to do with the state, with the user information. You can save in a computer whatever you want,
Mm-hmm.
but you still have a firewall, right?
Mm-hmm.
But whatever comes to the firewall, I mean, it may look like something, not harmful, and it may be harmful.
So is it an additional layer of security that you're putting in place?
That's right. That's
Is that what this is?
it's best practices. Yes.
Ah, okay.
So you're keeping the user ID safe because this is, I mean, you never disclose the user ID to anyone. That's why when you print your information in your accounts, you will never see your user ID. You will see your transaction ID, may see transaction ID, may see your information, but you'll never see your user ID. You have a user ID in a bank account. The bank information has your information and it has a user ID that only is unique to you. You will never see that number. That number will never be revealed to any user. It's irrelevant to you as well because what do you need your user ID for? What are you going to do with it? But still, it's so important because it identifies you. And by having your user ID, I can have all your information. Have you seen how the queries work, the SQL queries? You can find the user by a user ID. I just enter the user ID and I can find everything that pertains to you, everything. So you never save your user ID or show user ID to anyone. You don't save it in the servers. It's not good practice, right? So make them stateless. So they're disposable. There's nothing important there, right? The only thing that has value is whatever is in the user data, which is the bootstrap script to update anything. But every single instance created by the scaling group has that. So that doesn't matter if you lose one or scale in. It doesn't matter. They're stateless. There's no state here. You don't keep anything here. It's all stored here. And at the same time, they are connected to the instance. I mean, this is connected to the instances. But the information, the user information, the state is not safe here. It's not secure. And this is outside, right? Outside here, this here. DynamoDB is not in the VPC. Don't forget that, right? So DynamoDB will not have nothing to do with this section here. It's not a VPC based service. Okay. So if you want to get the information from here, then you have to come through these guys and find a way to this guy. But there's going to be another layer of security somewhere here, so you don't get to this guy, right? Does that answer your question, Mario?
Yep.
Good. So when it talks about the depth of your work queue, when you say queue is SQS, don't forget that. Okay. That's it has a queue of messages which are jobs. Every message is a job, right? So one of the ways to scale out is based on the depth of the work queue. The more messages you have, the more scale out you have to do, the more scaling out, right? So you create a auto scaling group to scale compute resources based on that queue depth, right? That's another way to just bear in mind that if you see it in the exam, that they mentioned this, that there's a solution you have to scale out based on the queue. That's true, right? So what the solution? Create a scaling group based on the depth of the queue. Pros: compute scales with job size, right? The job size, the depth of the queue. That's another way to see it, right? Providing efficiency and savings. Job can be completed in a shorter time frame. And even, my God, if a work item fails to complete, process is resilient. Don't forget that SQS is for decoupling, okay? So it's highly available, right? So the implementation is your work items from batch job placed in Amazon SQS queue as messages. The auto scaling group should be created to scale compute resources up or down based on Amazon CloudWatch queue depth metric. Okay, so batch processing servers retrieve work items from Amazon SQS to complete the job. We have consumers and producers in SQS, right? So you can have some SQS metrics here, right? So we have here approximate age of all this message, approximate number of messages delayed, approximate number of messages not visible, approximate number of messages visible, number emptied receives, number of messages deleted, number of messages received, number of messages sent message size. So you have some metrics here that you can analyze when you have SQS working. Okay. Let me see here. Okay. So this is why it says it's resilient. It says the AWS global infrastructure is built around AWS regions and availability zones. Here. There are three main parts in the distributed messaging system: the components of your distributed system, your queue, distributed on Amazon SQS servers, and message in the queue. In the following scenario, your system has several producers, components that send messages to the queue, and consumers, components that receive messages from the queue. The queue, which holds message A through E, redundantly stores the messages across multiple Amazon SQS servers. So your queue distributed on SQS servers. When you hear the word distributed, it has to do with microservices, highly resilient, highly available. That's why it's distributed in different servers, right? So, like I said before, you have producers, the ones that send the message, and the consumers, the one that process the message. There's going to be a visibility timeout time, which is the time when the message is not visible to the other consumers, and it's being processed, right?
Someone was paying attention to food webs when they did this.
I'm sorry, Maria?
When someone wrote that, the other window that you had open, producers and consumers, I was saying that someone was paying attention when they were learning about food webs.
Food worms?
food webs. Food webs. It's a biology concept
Okay. Okay.
that producers and consumers is a biology concept.
Okay. So the Bootstrap instance, Bootstrap is what we write in the user data. Remember those scripts that we wrote to install an Apache server and display some message in the browser? So that's a Bootstrap instance, right? The code releases happen often, creating a new AMI every time you have a release, and managing these AMIs across multiple regions is difficult, right? So the solution is develop a base AMI, a simple one, a base one, and then bootstrap the instance during the boot process to install software, get updates, and install source code that your AMI rarely or never changes, right? So when you come to uh, this section here and you create an EC2 instance, I don't know why I lost all the pins here. It seems that, Gabriel, did you notice that in your account? It seems that the pin items disappear after a while. Have you noticed that, Gabriel? In your account?
No, for me, the pinned items have always stayed there.
I don't know what happened here.
And you in the same
I mean,
account that you use
I
all the
can,
Yeah,
time?
yeah.
yeah, I'm in the same account that I always use. I can check now, see if they're still there. I haven't been on the console in a bit, so I can check.
That's weird.
But honestly, I don't remember them ever like not being there. You know what I mean?
Yeah, I pinned them. I don't know why. Disappear.
Yeah, no, mines are still there. Maybe you accidentally misclicked or unpinned them by accident.
Well, I have to misclip a lot of times because all of this was full of services.
Oh,
And of course, I will realize if I'm not paying attention after the first one, I will realize that I'm doing something wrong.
Are you
Because I had
using the same account that you use all the time?
yeah, but it seems that probably if you clear the history, I cleared the history yesterday. I don't know if you have something
Ah,
with that,
maybe yeah, that might have
but I
cleared
cleared the
some
history
of.
of my computer. I don't know why it has to do what it has to do with
It
that.
might have cleared the cache, like the cache
Probably
on
probably this
AWS.
cache. Um, a ping is like a cache, similar to a cache, something that
Yeah.
is
No,
there.
no, no. I'm saying like on the website. Like it might have cleared the cache of the website, so all the metadata of the website, like your pings and your cookies and all that, that might have been erased, which might have been why.
Let me see if it is true.
See, look, it deletes cookies, cache, images.
Yeah, but that's inside my account. I don't know why it affects my AWS account. That's weird. But it's gone. Okay.
Okay, so now it's
Let me
gone.
try now. Let me
Go
refresh.
there, refresh. Yeah.
Let me go out. Let's see what happens. Now I have to authenticate myself with MFA.
Yeah.
Yes, it disappears.
Yeah.
Yes.
It's a
See how
cache.
interesting. Very interesting.
Yeah, I figured it was like it clears when you clear your history, all of your history, it clears your cache and your cookies and all that is website specific and it's stored on your computer.
Very
So
interesting.
it's stored not on your computer specifically, but more on in Chrome. It's stored in Chrome. So if you clear all of that, it all your cookies, all your cache gets deleted and all the metadata for each individual website gets deleted. So you're gonna have to you're gonna have to pin them again.
Yeah, but that's weird because this has nothing to do with Chrome. I mean, this is
I don't know, maybe
it's open in
maybe
Chrome,
save
but
it, and you know what? Save it. Save one, and then go back to your cache and see where is it low. It must be saving it somewhere.
yeah, no, maybe AWS just has it set up like that where the metadata, at least, your pins, your settings for your account and stuff like that, that's stored locally, on like on your Chrome folder, like, wherever that's located on your computer. And then when you clear your history, and clearing your history clears all your cache, all your cookies, and that's all the metadata for your specific account on your specific machine. So if you clear all that, everything in terms of settings and pins and all that is will be gone. It's kind of that's kind of ironic though, right? It's a cloud web they're a cloud company and they store your cookies and and your browser metadata locally. That's funny.
Very interesting.
It's kind of ironic too, yeah.
Okay.
Yeah, no, I'm just saying like being AWS and like them being like a big cloud infrastructure. Um No, not just a Chrome specific thing. It's a browser thing. Cache in a browser is useful to make loading sites quicker. Yeah, exactly. Yeah, Brian. Well, yeah, exactly what Brian just said.
What do you say?
In the chat, he was like, it's not just a Chrome specific thing. It's a browser thing. Cache in a browser is useful to make loading sites quicker. I had a problem with my website where I wouldn't see updates I made to the site on my computer, but my friends could see the updated site. I had to delete the cache, to solve it. Yeah. So yeah, I guess it's like a browser thing. But yeah, it's a cache and a browser thing because your cache is stored in your browser and then your browser is stored on your computer locally wherever that is. And then yeah.
Interesting. All right.
Mhm.
So we develop an AMI, basic AMI, and then bootstrap the instance. Come here, we create the instance, right? And then when we come here in the third page, right? So we have a section here that we already know, right? This section here is when you put all the bootstrap scripts, right? And this is it happens at runtime. So whenever you run the instance, it will install all the um, updates, packages, softwares, whatever you have here. Okay, or you can have a customized.
Oh, sorry. So you can save, can you go back for a moment? Can you say, once you put that user data, right, at the bottom, can you save this configuration with that user data, or do you have to keep that user data somewhere else and put it in there all the time?
Okay, if you're using an auto scaling group, it's going to be saved in the launch configuration. So whenever you create an EC2 instance, it's going to have that.
And if you don't?
If you don't want, if you don't
do an auto scaling,
then it will be specific to this instance only.
So okay, so let's say that I want to create a couple of instances that are not going to be in an auto scaling, but I want to use the same bootstrapping.
Okay, you can put a number here, say 10. And put the use.
No, but I'm not going to create it all at the same time, right?
Oh,
so
then you
let's
have to
create one, and maybe next month I need to create another one for whatever reason.
If it is this way, you have to do one by one. If it is this way.
Oh, so you cannot create a custom AMI with that user data in it, the templates. You know the AMI templates, right?
That's another way. You can do it this way, and it has to be one by one, or you can have a custom AMI that already contains the updates and the softwares and all that, and use that AMI to create the instances. But it's going to be one by one if you do it this way. So still, when you create the AMI, you have to choose it here. When it says my AMIs, for example. In this case, I created one. So you create yours, your custom one.
Mm-hmm.
And every time you create an instance, you will have to use this. The only way that you can automate that is using auto scaling. If you don't use auto scaling, it's going to be manual.
So, something about when we were working on the project, we had created an AMI instance that had a specific EBS with specific configuration, and we saved it so we can reuse it. But then when we try to use it again, it will not bring in the changes that we have saved with the original one. What do we do? What do we do wrong? So we had a specific EBS with specific IOPS. We had, what else was it there?
Okay.
We have made some changes, right? And we say that.
Mm-hmm.
as a safe configuration on my AMI, but when we try to pull it back again, we have to do the whole thing all over.
Okay, what you can do is create a Lambda function,
Uh-huh.
create a cron job, and the Lambda function will create instances for you. If you want to automate the process, you can use Lambda for that. So you create a cron job, like I show you guys, like every day, a specific time of the day, and then that rule would trigger a Lambda function. The Lambda function will create the instance for you, or it would use a Lambda function. We use a CloudFormation template and automate the process and create that for you.
So probably cloud formation template will be
Yeah, I think that's the way
a
to
better
go.
way to go, right? Because there's no charges with the cloud formation.
Right, and you can use it's repeatable code. You can use it repeatedly. So you can create a launch configuration with CloudFormation in auto scaling group 2. And you can create instances. You can trigger an event with Lambda, and Lambda can grab that CloudFormation template and create instances. So that's possible. But if you want to do it manually, that's the way to go. You have to grab the AMI and create the instance manually. You can automate the process, and I think that's more convenient, right? But to my understanding, the AMI doesn't it doesn't contain the EBS volume. What it contains is a software, and the whatever the instance needs to run, but the ABS volume is something apart. Even when you create,
Will it keep the user data that the bootstrapping that you have done, you have saved with?
I don't think so, because
not even that. Wow. So what kind of customizations does it save?
It has the software and the operating system.
Okay.
It has the Linux operating system here, right? So whenever you create an instance, you have to have an AMI. That's for sure, right?
Yes,
but what part of the process is choosing the EBS volume? So the EBS volume has nothing to do with the AMI. So if you continue here, you go, you have to choose the storage. So that's something independent from the AMI. The AMI doesn't contain the volume. The volume has to be created by you, has to be attached, right? The AMI, if you put here AMI, AWS, it contains the snapshots, right? But not the volumes. For instance, store bat AMIs, a template for the root volume of the instance. For example, the root volume is this. Let me show you here. This is the root volume.
Yeah, the one that you choose.
The one that comes with it.
Yes.
Right?
Yeah.
But if you have to add one, you can include it in the custom, but it has to be a snapshot.
Well, actually, you know what? Not even the root volume. We made a change to the root volume, and it didn't even save that. We had to recreate it all over again.
Yeah.
So the customization has to be on the prior window, perhaps.
Yeah. And it has the operating system, the application server, the applications. It has the launch permissions, because it may be locked by the owner, right? A block device mapping specify the volumes to attach to the instance when it's launched. Okay, so it maps to the volumes that it needs, but it doesn't contain the volumes, right? And it has a template for the root volume. The template for the root volume, not the root volume, right? So it's something that is compatible with the root volume. AMIs are region specific, right? So you can copy an AMI within the same region, right? If you're gonna do it in the region, then the person will have to create when it's another region, the person will have to create a snapshot of the instance, and from that snapshot, make an image. Okay, so let's say that you have an instance. Let me see here. I'm gonna launch it. See here, it's running here. You can create an image. So the person can share the image with you, but you have to have the permission to use that image. Okay.
You have one called My Image. You want to change the name?
Hmm?
You have one called My Image, I think.
Come on. So now let's say that, for example, this is in North Virginia. Okay. Let's say that now I want to launch an instance in Ohio. Okay. So now when I look here, my AMIs, I don't see anything.
Mm-hmm. It's a different
region specific.
Mm-hmm.
Right. Now, if I launch an instance here, I'm still creating it. That's why I don't see it. But yes, that's the way it is. So the region specific, like I said before, let me see, it's available now. Now I can create an instance. If I come here, dashboard, I can use it here. And then my MIs is right there, my image, right? Now, let me see here. If I take a snapshot, instance, volume. So the volume that I'm using, this is a snapshot here. There's a snapshot here somewhere. Snapshot here. Okay. You see? I can create an image. Right? Now this image.
Are you creating it from your tablet?
I'm creating from the snapshot of the volume.
Oh, the snapshot. Okay.
So I can say my other image. create an image here. So if I come here, I have another image here. Okay. So if I see the permissions here, it doesn't have any problem here. My machine, VS volume. Okay, let me see if I can see it in another region. Still cannot see it. So it's a region specific service. Okay. You see, there's nothing here.
Mm-hmm. So the best way to do this is with a template then.
Mm-hmm.
Or yeah, with a template.
Yeah, and there's way to update the
CloudFormation, it's non-region specific, right?
Which one?
CloudFormation, you can have it's attached to your account, not CloudFormation.
Yeah, but you have to specify the regions too in a CloudFormation. CloudFormation, you can use it in a region, but when you create resources, you have to specify the region. So whatever you do in the console, exactly as you do in the console, is the way you do it in CloudFormation. When you choose, if you create an EC2 instance in CloudFormation and you don't specify the region, it's gonna use the region by default, which is North Virginia. Right? This is the default.
But okay, so you have to specify where you want the template to be launched.
Yeah, same thing. If you specify the availability zone, it's going to put it in default. In the default one, it's going to choose whatever availability zone is in that region. If you don't choose the subnet, it's going to choose the subnet. You have to be specific for your architecture to be organized.
Can you pass through a region to the CloudFormation programmatically, or do you have to update the template? In other words, you're running the CloudFormation template, but you're passing on that variable to get the CloudFormation to be specific to that region without having to go into the template itself.
Yes, you can use parameters.
Okay.
You can use parameters. So parameters is something that is used whenever you think that your template may change in the future. I use parameters. That's one of the, right? So for example, if I create a template, let me see here real quick. This is more important than what we're seeing now. Let me see if I can find here. Are you paying attention, guys?
Yes, I am.
This is something different. This is JavaScript and HTML. One moment. Let me see if I can create a file for this. One moment. So, one moment. Okay, one moment.
I have a question. Has anybody here have installed Linux Mint on and converted a Windows computer to Linux using that?
I did it on the
Windows
virtual
laptop.
machine.
Yeah, converted a Windows laptop to a Kali machine.
To a what? What did you say?
Kali. It's Kali's Linux based. It's basically has all the hacking tools that you might need. But it's Linux based.
Okay. Does it work well? Have you tried it?
Yeah. Brian is the one who gave me the idea.
Oh, really? Send me the info, please.
I did the virtual machine. That worked well.
No, but these are machine. I have two computers that their hard drive, it's really small. It's 32 gigabytes and they don't update Windows. I have to put a separate stick to it, a separate drive, external drive, to be able to do the upgrade. So Linux uses, it's less demanding on resources on the hard drive. So I wanted to turn them into Linux machines.
Perfect.
Yeah.
That's perfect for Linux.
So I was looking into Linux Mint, which kind of like a graphical user interface, kind of like Windows in a way, but it's all Linux.
I'm taking Linux Plus right now,
Uh-huh.
and everything's pretty much in Ubuntu so far.
Really?
Yeah.
That's interesting.
So Maria, you're doing this. For example, you create your parameter, right?
Uh-huh. I'm looking.
Okay, the default one is US East 1, right?
Okay.
And then you want to allow some values. So you can say that you can choose this one as well.
Uh-huh.
Or you can use US East 2,
Uh-huh.
or you can say US West
Uh-huh.
2, or you can say AU West 2. All right, that's the Europe. All right.
Mhm.
So now I'm gonna say, for example, description, and say enter. Right. So that's fine.
That's awesome.
So you have the parameter here, and then you create the resource, right?
Mhm.
Resources. And then we say type, the name, my new instance. And then the type is going to be AWS EC2 instance, right? And then we're going to say, you see, I have an example here. Properties. Then we say image ID. I'm gonna worry about this later. Let me continue with this. Image ID. What is the other property that we're gonna use? Oh, security groups. I'm gonna worry about this later. And then want to say
Yeah. I'm gonna have to pass the
region
the
or that particular property. Because for regions, what you use is a mapping. Mapping is what what is used for that. But I just wanted to show you example. Let me see here. No, there's no property for a region. There's property for availability zone, but not for region. One moment. Yeah, mobbing is what is used for that. Okay, so I'm sure that it can be, there should be a workaround that, but I'm gonna show you how parameters work. Okay. So I'm gonna say here, availability zone. Then we use the ref function and we refer to instance. And then we're gonna call it AZ instead of region. Right? Now image ID, let me find one from here. Let me choose this guy here. Okay. Put it here. Right?
Mm-hmm.
Here, group, let me create it here. Okay, group here, right? And then type, it's AWS EC2 security group. Okay, property. Group description is the one that comes now. Group description, yes. So we say this.
Remember to change the in the top.
And then, yeah, I have to put it here. Yes, so we can, so we put here.
Oh.
Right. So I'm gonna say here, this security group allows port 22 access. All right. So now we say security group ingress, because we only worry about the inbound traffic. We don't care about the outbound traffic. Security groups are stateful, so we don't worry about that. So now we're gonna say, yes, we're gonna say IP protocol is gonna be TCP. We're gonna say from port 22 to port 22, and then we'll say CIDR IP. We say 0, 0, 0, 0, 0. Okay. So I think that this is, let me put here A. Right? So this is the instance AZ parameter. And then description here, I think this is fine. Let me use CloudFormation and this template. So we call it sample YAML. So we come here, let's see if it works, okay? Sometimes you may have some issues along the way. So I'm gonna upload a template. We come here, it says sample right here, YAML. Let me see here, and then what happens? Format arrow. Oh, I forgot one column. Okay, not a problem. It's right here. So I have loaded again. Sample. And then, hey, what happened? Sample, open it. Next, you see how it gives me the parameters? You see, just in case it changes in the future, I can update I can run this again and change the availability zone. That's how parameters work, right? So I can choose US West, EU West 2, and then continue, say my Europe EC2 instance stack. All right. So I come here, just create this. Let's see what happens. And it creates this stack here, and begins to create the resources. We come here to resources. The security groups in progress is super fast, super quick. It's already created, and then it begins to create the instance.
So you don't tell it the region. You tell them the availability zone within the region.
Yeah. I just made this up. This doesn't exist. All right. Let me use the same region and put this. Okay. All right. And now I'm gonna delete this guy. So I come here to stack and say delete, and then it deletes everything. I'm gonna create it again, and then update the file again, upload the file again, come here, sample, and then I come next. I choose D, for example, and then is my new stack, EC2. Okay, whatever name you want to give it to. And then create the stack and begins creating the stack. So I refresh this and I look at the resources. This is real quick. Okay, it's already complete. And now it begins to create the instance, and it create fail. Invalid availability zone EU West. Oh my God, I have to change this. You see? That's why you have to read carefully when you create these kind of things, you know. Same thing again, you gotta be patient. And then I load here. And then we come down here and sample. Say next. We choose, for example, D. And of course, the description that I put is right here, right? And then I'm gonna give it a name, whatever I wanna give it a name. So now we go, and then begins to create. If there's another error, I'm gonna leave this and continue with the class. Created that. And then I begin to, security group is created. Created the instance, and then if I go to my EC2 instances, there should be an instance that has been created, right? And it's already running. Now it's being created here. Oh, I didn't specify the, you see, I didn't specify the type, and it shows M1 that small for me. Okay, which is not in the free tier. Okay.
Why did you choose that type? Why did you choose that type?
By default.
But didn't you give it the AMI type?
Well, yeah, but the AMI has nothing to do with the type. I have to choose the type, the instance type.
Oh, the instance type, sorry.
Yeah, I have to choose the instance type, and I didn't choose it, so it gave me this one, which is not in the free tier.
Based on what? That is interesting.
Very interesting. Okay. So I'm gonna delete these two guys because I don't need them, right? Well, actually, I'm gonna delete this one, and then the other one is gonna be deleted when I delete the stack. Okay, because the stack, what it does is it rolls back and deletes everything that was created. All right. So guys, let's take a 10 minutes break. It's 2:29. I see you again at 2:39.
Okay, we'll be back here.
Okay, so we continue with this slide here. So we were saying that you develop a base AMI and then the bootstrap the instance, then bootstrap the instance during the boot process to install software, get updates, and install source code that your AMI doesn't have to change. So the pros is you do not need to update the AMI regularly and move customized AMI between regions for each software release. So implementation, you identify a base AMI to start from, create a repository where your code is located in code commit or GitHub, right? All the packages and configs that need to compute need to occur at launch of the instance. And during launch, you pass the user data to your EC2 instance that will be executed to bootstrap your instance, right? So it's like I show you in the user data section of the instance, right? So this is an example of bootstrap instance. So we have the launch configuration, the type. Of course, this is a CloudFormation template, right? You're creating a resource here, a launch configuration. The type is going to be AWS column, auto scaling, column, launch configuration. And by the way, guys, you can do this exactly in the same in the CLI, in the command line, okay? So we have a comment here, comment 2, and then AWS CloudFormation init, we're going to initiate the process, right? And then we have the packages here using yum, which is a package manager, right? For bash. And this is HTTPD, which is Apache. And we're installing PHP as well, right? So the sources where this code is gonna be in, this index.zip is gonna be, is in the Amazon S3, and it's gonna be inside this particular HTML, or in Amazon S3, depending on the source that you're using, right? We have other things here like enable that the HTTP Apache is running, it's true, and ensure is running true. And this is more of a configuration side of the Apache server, okay? But this is basically it. You put the bootstrap code there, and when the instance is launched, this code is going to be run. Okay. Stream processing example, the Amazon Associates program. Okay. In this case, we have a registered Amazon Associate that adds a link to Amazon.com in the website, right? A user visits Amazon.com by using the Associates link and makes a purchase. The Amazon Associate earns advertising fees for qualified purchases as a monthly payout. Okay. I don't know if you guys have participated with this. I participated once, but I got tired of that because it's not, I mean, you may have this in your website, but you need traffic in your website so you can sell, right? When you click on this,
a lot of people that are blogging are doing this.
Yeah, and it pays you, they pay you like up to 15% of the purchase. Okay. It's a way to, have some passive income, but it takes time. It takes time and dedication, right? I had some, I don't know, guys, if you ever had any store online. I had a Shopify store once, and I purchased a few stuff from China. But I decided to purchase, whenever you have a business like that, purchase something for you. and see how the product looks before you sell it. I did the opposite. I saw the product, I made a few sales, but one day I decided to purchase it for me and give it to my mother because I was selling purses, right? And then I when I saw the product, it was so pitiful that I decided to close my store because I was selling something that I wouldn't give even my mother, uh, let alone someone else that I don't know. And I like to do things right. I like to sell things with quality. If I want to sell something, I don't want to sell, you know, Mickey Mouse stuff and then make money out of that. Because at the end of the day, someone is gonna backfire you. Someone is gonna return the item, and that's gonna be a problem for you. All right, so we have the Amazon Associate Program. With this program, you add a link to Amazon.com on your website, right? And if people use that link and buy something, Amazon will give you a share of that sale up to 15%. Okay. So how much to pay each associate every month is an extremely important problem. Right? It is critical Amazon is correct, but still it seems like a fairly straightforward problem. Amazon tracks every sale that is attributed to an associate link, adds up the sales at the end of the month, and pays the associate at the appropriate rate. The reality is a little more complicated though, because Amazon must track an order throughout its life cycle to know where the order was canceled, whether the order was canceled or returned. So this slide illustrates the system that Amazon built over 12 years ago, a single threaded C++ application connected directly to the production orders database every 2 hours and exported the orders that it was interested in into a series of flat files. Next, another C++ application ran once a day to aggregate the bi-hourly files into a daily view. Finally, another system ran once a month to scan over the daily aggregates, calculate how much to pay people, and give that information to the payment service, which was run by a totally separate team.
This is very.
Sorry?
Sorry, never mind. My comment. I was unmuted.
Okay. So this system ran very smoothly until about 2008. I'm just reading here. This is historic information. Okay? This system ran very smoothly until about 2008, when the scale of the associates program grew to the point where the daily aggregation system started to run out of memory. The program needed a way to process large volumes of data quickly. All right. So this was working perfectly until 2008 when they ran out of memory. Okay. Now, the solution is Amazon EMR. And what is Amazon EMR? It's a managed platform that simplifies running big data frameworks such as Apache Hadoop and Apache Spark on AWS Cloud. So what is Hadoop? Hadoop is an open source project written in Java and is managed by the Apache Software Foundation. It uses a distributed processing architecture called Amazon EMR, Elastic Map Reduce, in which a task is mapped to a cluster of commodity servers for processing. Each piece of work that is distributed to the cluster servers can be run or rerun on any of the servers. So the cluster servers use Hadoop distributed file system to store data locally for processing. The results of the computation that is performed by those servers are then reduced to a single output set. One node, which is designated as the master node, controls the distribution of tasks. The master node can automatically handle server failures. So we have some of the benefits of Hadoop. It says it's built for handling uncertainty. So if you take a look at this, when it ran out of memory, I believe that there was a lot of uncertainty, right? Handling high data variety, volume, and velocity. What happens when the application grew and grew and grew? They ran out of memory, right? Providing solution flexibility, write your own data applications, and processing large batches of data, such as logs, right? So that's one of the solutions to this problem that Amazon itself had in 2008, right? So maybe they give you a little history, a little bit of history about, the background of that problem, what happened before the problem emerged, right? So this is a service that AWS has that I believe that probably the students that took the cloud practitioner exam saw it in the exam, probably, if not in the actual exam, I'm sure that they saw it in the practice exams somewhere. Right? So the other solution is Amazon Redshift, right? Which is a database, a data warehouse, right? For large, large bunches of data at scale, large scale. It's a fully managed petabyte scale data warehouse service. It's provisioned in minutes. It monitors the performance of your query. By the way, it uses SQL, resize via point and click, use built-in security, and configure automatic backups. Okay. With other types of databases, and you have to somehow you have to manually back it up or automatically, depending on whatever that has. But this guy has built-in automatic backups, right? So you can configure that, right? And security, you don't have to worry about that. By default, everything that is saved in Redshift is encrypted. So you don't have to worry about encryption, right? So to implement Amazon EMR as a solution for the Amazon Associates Programs Architecture, there was a team there that developed a system that publishes the raw orders stream to a set of registered listeners. So the Amazon Associates team wrote an application that listens to the order stream, filters it, retrieves any additional data it might need about the order from other services, and places it into Amazon Single Storage Service, S3, and then a Hadoop cluster starts on a daily basis, and it pulls 60 days of order history out of Amazon S3. It adds the month-to-date sales of every associate, computes pay rates, and stores all of the data back onto Amazon S3. After the architecture adopted a distributed solution, larger and larger data sizes no longer posed a problem. As the volume of data grew, the Amazon Associates team did not have to struggle to figure out how to fit the data in memory on a single machine. All the team needed to do was to add machines to the cluster. The code that runs in the cluster doesn't change at all. So, super good solution, huh? If you study big data, this is one of the services you're gonna see in the big data examination, EMR. Okay. So there are significant advantages to Amazon EMR. The cluster setup and resizing takes minutes. Okay. You can create application-specific cluster configurations. A container managed service makes software installation and upgrades trivial, super simple. And the cost is usually much lower. So the total cost of an on-premises deployment in comparison to Amazon EMR includes the time and expense spent in sizing and ordering hardware, the development effort, and the cost of maintaining the system and administrative personnel. So this is a good use case. And probably you heard EMR before and actually didn't know what it's used for, right? But in this case, we have a use case where the system was running out of memory because there were a lot of associates being added or joining the program, right? And the data was just overflowing, a lot of data. So they needed a big data solution, and they came up with EMR, right? And then Redshift as well. So these two guys solved the problem that Amazon had for this particular Amazon Associates program. Okay. So what's next? Generation 2, right? The associate program, the generation 2 of the associate program. They achieved the following changes. The file system was replaced with Amazon S3, right? So they have this file system before. They're now using Amazon S3, which is virtually unlimited, right? Amazon EMR was used to remove the performance bottleneck that was caused by a single-threaded C++ application. So this was just a single-threaded. Can you imagine a multi-threaded application, right? And they were still having problems with the single-threaded one. And then he added analytics and data insight. Well, this is one of the benefits of Redshift, that you can have data insight and analytics, right? So how can this system be further improved with the load increases? So one of the improvements that Amazon thought about was adding real-time data processing, right? And in that case, we have another service called Kinesis, right? And Kinesis has 3 flavors: Kinesis Streams, Kinesis Firehose, and Kinesis Analytics, right? So there's a comparison here, batch versus streaming. So for batch processing, you use cold data. What is the meaning of that? Is that the data is stored in a specific container or data storage service, and then you retrieve the data from there. So the data is cold. And you have hot data, which is real time or near real time, right? So for batch processing, there's hourly server logs. The system issues for an hour ago, right? Weekly, monthly bills, spending in past billing cycle, daily customer preference report from clickstreams logs, and daily fraud reports. Was there fraud yesterday, right? So it shows you the daily fraud report, right? For streaming processing, the compilation is about metrics, right? So use a CloudWatch for that, which monitors the issues immediately when they happen because it's real time, right? Real-time expanding alert caps. So whenever you have an application that is running, Kinesis is getting all the information directly, and immediately in real time, which is pretty good, right? It analyzes it in real time as well. And it detects fraudulent transactions or fraudulent activities in real time, which is pretty good. All right. So stream processing compiles Amazon CloudWatch metrics immediately. And it also monitors issues, and it all happens in real time, which is, very efficient and helpful. We have this guy. This guy is a very important guy when it comes to big data as well. If you study big data, which is called data analytics right now, that's the new name for the certification, Amazon Kinesis is going to be there for sure. So what do we do with Amazon Kinesis? You can collect, process, and analyze videos and data streams in real time. There's one, guys, I wish I could find that lab that I did for serverless applications. By the way, Kinesis is used in serverless applications as well. And then you can create an application using Kinesis, and it's about some unicorns that move from one side to the other, and it registers all the coordinates of the unicorn while it's moving in real time, which is pretty awesome, right? And by the way, it uses producers and consumers as well, like SQS. Amazon Kinesis uses consumers and producers. Okay? It has a producer client library, and it has a consumer client library as well. So what happens here is Amazon Kinesis video streams is a fully managed AWS service that you can use to capture, process, and store video streams for analytics and machine learning. It's even used for machine learning. Okay, and machine learning is very hot nowadays. It's very popular. People are using machine learning and artificial intelligence a lot, right? So you can use Amazon Kinesis data streams to collect and process large streams of data records in real time. With Amazon Kinesis data streams, you can build custom applications that analyze data streams by using popular stream processing frameworks. And now you have Amazon Kinesis Data Firehose, which is, once the data is analyzed or processed here, you can send the data back to a specific place. It could be either Amazon S3 or Amazon Redshift or Elasticsearch service or Amazon or a Splunk, right? So you can use Amazon S3, Redshift, Elasticsearch, or ES, and Splunk, okay? So when the data comes from outside, from the producers, is analyzed using Kinesis in real time, right? And then after it is analyzed, also using analytics, we analyze data stream with SQL, right? It can be sent back to or put in the 4 places that I just mentioned using Amazon Kinesis data host, Firehose, I'm sorry. Okay, so Amazon Kinesis video streams is for data streams is for analyzing the data, right? And then Firehose is to put that data in S3, Redshift, Elasticsearch, or Splunk. Okay. So let's go one by one now. Let's talk about this one now, data stream. So it's a near real-time performance. It's near. It's not completely real time. It's near. That's a lot. Still is very significant, right? So you can perform, right, continual processing on streaming big data. Processing latencies fall to a few seconds. Is super fast, right? And compared with the minutes or hours associated with batch processing. So if you have to choose between this guy and this guy, this one is more efficient because it's using near real time and it's faster than this one that uses cold data, right? So build near real-time apps. It's not only about analyzing, it's also about building, right? So you can use the libraries, the client libraries that enable the developers to design and operate near real-time streaming data processing applications, right? So once you have the application, you can integrate Kinesis with it, and then you can do data processing in near real time. It's elastic, right? And it has a high throughput because it scales seamlessly to match your data throughput rate and volume, because the data is coming in at a specific rate, right? So you can easily scale up to gigabytes per second. It can scale in or out based on operational business needs, and is very efficient, cost efficient, right? Is for workloads at any scale. Get started by provisioning a small stream and pay low hourly rates only for what you use, right? So you pay what you use. So we have here, we can come here, it says Kinesis. And then you have data stream, data Firehose, data analytics, right? So you can create a data stream here. I have an application here. When did I create this? Oh, this is the one. This is the one for the unicorn. Okay. Oh, I was back in February 24th. On February 24th, I hadn't deleted this. So thank God it's not running or anything. So I deleted. So we can come back here and just come to the dashboard and create a data stream. You know, you give it a name. Of course, you're going to use shards. Sharding is like partitioning, like a database, right? And you use shards, right? The more shards you have, the more highly available you're going to be. Just think about like shards. Think about partitions, or think about availability zones in an instance. Okay. Merging is scaling. It's called merging in Kinesis. When you scale in, you merge it. When you scale out, it's reshard. Okay. So you can create this, and once you have created that, you can have fire hose here. And then the fire hose is a delivery stream, right? Because you're delivering your data to these places that I mentioned before, like a S3, or Elasticsearch or Redshift or Splunk, right? So you give it a name, you choose the source, where's it coming from, and then you continue. I haven't given it a name, just give it a name, whatever, doesn't matter. And then transform the records, just in case you want to transform the source records. And then you do continue, and then you have the destination here, right? So once the information is analyzed, the data, you can put in this one of these four destinations, right? So this is a Twitter trend analysis application. So let's view an example of this. So the planned functionality for the Twitter trends.com website is to display the top current trends on Twitter. So on AWS, you might begin by creating a basic AWS Elastic Beanstalk website. Okay, you're using Elastic Beanstalk to deploy your application, right? Unfortunately, the Twitter Firehose feed is quickly becoming too big to process on a single machine. It's similar to the problem that Amazon had in 2008 with the associate program, right? The data is growing and growing and growing for a single machine. So you will need to divide up the work so it can become in parallel on multiple machines. So the workload must then be combined into an output that can be vended by the Elastic Beanstalk web server. So in this case, what you can do is you could compute a top 10 value, a logo 10 value for all the tweets coming into processing instance, and then combine all top 10 lists into a global top 10 list in the web server. So the problem with this is that without some sorting or grouping function, each processing instance will receive a random selection of tweets. The situation makes it impossible for any one instance to know how many tweets are occurring for any specific topic. So what do you think is going to be the solution for this? And we saw it before. What was the solution for Amazon problem? EMR, right? So we're going to use AMR again, the technique for EMR. It's right here. So you can solve, this looks horrifying, right? It's scary, okay? But the logic behind this is just simple. That you're using Elastic MapReduce, right? And if you computed the top 10 tweeted topics for a standalone batch of tweets, you can treat the topic of each tweet as a partition key. For example, /World Cup. Right? And then each map from MapReduce task would take in a fraction of all tweets, group them by topic, and send the count for each topic to the appropriate reduced task that is responsible for that topic. Right? Guys, you don't have to become an expert in this. It's just understand it, right? You understand the logic behind it, right? So you can do something equivalent by introducing an immediate stage that takes in the stream of tweets. So what is this intermediate state right here? Stage right here, kinesis, right? And then you order them by topic. So each processing box, right, would then pull only the tweets for the set of topics that is responsible for, right? So this would enable each box to be an authoritative counter of tweets for some subset of all currently active tweet topics. This process is essentially the streaming equivalent of the MapReduce processing paradigm. Okay, so we use this intermediate stage to stream all the tweets, and we order them by topic. The tweets are coming from here, right? They're streaming here, right? And this is all real time. So we're using the sharding here, the sharding. Remember that, well, don't remember, I'm saying to remember because we've never seen this before. The more EC2s you have, the more servers you have, the more shards you would need, okay? To avoid something called hot partition, right? Every shard has an ID, right? It has an ID. And you don't want all the tweets, in this case, tweets going to one partition only, to one shard, right? So you want to have enough shards so you don't have a hard partition, right? Or a hard key, a hot key, sorry. Hot partition, hot key, right? Okay, so we have 3 apps here, Kinesis apps, that are just getting the top 10. Okay? You have a worker here, partition key, right? That's what I talked to you about now, partition key. And you have the streaming coming here. And then after you have all these guys, your application will produce the global top 10 tweets, right? So before, it was a problem because all the data that was going in was a lot, right? A lot of data coming in, right? And the application, the last TB stock application was not able to cope with such a big data. So by using Amazon Kinesis, right, and sharding, you can make this seamlessly easy and then be able to process that, okay, by topic, right? And then the top 10, right, by topic, right? And then the application will process that and just give the user the 10 top tweets, right? This is a high-level explanation of this, graph here, right? So here, this example, we have, all the orders that are coming in, they're pushed to Amazon Kinesis. The orders here, order data, right, for Amazon. So if the order is linked to associate program, that is a qualified order, right? That order information is stored in Amazon S3, right? So because the qualified order is mapped to a specific Amazon associate, the information can be stored in Amazon DynamoDB, because DynamoDB is used to store the user's information, in this case, the associate. So the associate can log into a web application to see how many people came to their website and purchased a product at Amazon.com, right? So the Amazon EMR cluster receives the qualified order information from the Amazon S3 bucket. And then the monthly total is stored in Amazon Redshift. A business application, a business intelligence application, or BI application, can then run some analysis on the information, right? A business application, business application service, we can have this guy here. I don't know if you have heard about this guy. Maybe you saw in the exam. Do you see your exam in the cloud practitioner, guys? Probably. Quick site somewhere.
Yes.
So QuickSight it's a service to visualize your data, right? So you have here, you can manage your data here. You know, these are data things that I did before. So I can create analysis here, and then it gives me like some visual types. I can choose a gauge chart or a donut chart, for example, here.
Oh my God.
I can use date here and add a value, maybe put here something here. It gives me some data here, like count of closed opportunities by date. It tells me here December 29, 2016, 0.0K count, you know. I can use another visual type and use here this area line chart, right? I can use this vertical stack 100% bar chart, and it will give me this, right? I can use this KPI, key performance indicator, and it will give me this now, minus 11%, right? And it all depends on the data that I choose here, right? I can create I can create a story if I want to, just if I want to present my data in a presentation like. I can use parameters, I can use actions. I can have add another visual, right? And have another one. And for this one, I want to choose this stack bar combo chart. And then I want to bring, for example, let's say lead name here. This takes a little business understanding, right? Maybe salesperson here. And then it begins to form the chart for you, right? So this is a BI, a business intelligence service that you can use. Looks like a third party because you go out of the console, right? This is the console. You go out of the console, but it belongs to AWS, right? So if you're interested in visualizing data for your business or your company, QuickSight is a good service and it's free.
Where is the data coming from for this?
You can bring it from S3. Okay. Let's say that I wanna, let me see if I can come here. What is it? I come here and then I want to do some new analysis here. For example, let me choose a new data set. I can upload a file. I can bring it from Salesforce, S3 Analytics, S3, Athena, PostgreSQL, and MySQL, Redshift, SQL Server, Aurora, MariaDB, Presto, Spark, Twitter, GitHub, AWS IoT Analytics, Snowflake, Teradata, Jira, ServiceNow, Adobe Analytics, Sales Pipeline. All these guys, I can bring the data from all these guys. So if I choose S3, for example, I'm going to choose anything, and I can choose from here, and I have to create a manifest, right? I have to create a manifest that contains the URI where the source is, you know, the URI of the bucket, right? Mm-hmm. And then when it's run, it's going to bring the information from the S3 bucket, okay? And it's going to put it in a table of format, like rows and columns. Or you can use Amazon Glue to transform the data, and use Athena, which is here, to query the data interactively. Okay, so QuickSight is another service for big data. Okay, and it's used for visualizing. If we go to QuickSight,
did you say that QuickSight could replace Tableau?
Which one?
Tableau or Google Data Studio?
I'm not familiar with that one. So Amazon QuickSight is a fast business analytics service to build visualizations, perform ad hoc analysis, and quickly get business insights from your data. And also QuickSight seamlessly discovers AWS data sources, enables organizations to scale to hundreds of thousands of users, and delivers fast and responsive query performance by using a robust in-memory engine called Spice. Of course, when you create a QuickSight, you're going to have Spice. You're going to be limited by Spice. Okay? It's right here. Spice capacity for this region, 11.2 megabytes of 1 gigabyte. Right? So Spice is what limits your data. And Spice is it's an acronym, you know, that stands for in-memory engine. In-memory engine. Let me see here. Let me see what. Okay. Spice. I forgot what it stands for. Super fast parallel in-memory calculation engine. Right? That's what it stands for. Super fast parallel in-memory calculation engine. That's the brain of QuickSight. Okay. It's business intelligence. Whenever you hear BI, you know, BI, it has to do for sure with QuickSight. So the sensor network data ingestion and processing example, flu outbreak heat map. Okay, so we have scenario here, the influenza outbreak around the world. So the mission is based on the data you collect, right? And generate heat maps to understand public health. So in this scenario, the government health organization wants to understand a flu outbreak that is happening around the world. Their mission is to understand the state of the public health by collecting data and using the data to generate heat maps. Okay, so that's the problem, right? So we have a generation 1 flu heat map. So this scenario is based on a real world example. It is not rare to see a government organization that uses very basic technology. It's very common. So in this case, all of the federal offices send the flu data to a central file transfer protocol, or FTP server. So this solution does not scale. And the FTP server can become a single point of failure, right? So everything comes to this file server, and we only have one server. So if this server goes down, that's the single point of failure, right? So because of the nature of this file system, this solution does not generate a near real-time heat map for flu cases, right? So could you use Amazon Kinesis? So the issue of Amazon Kinesis is that its payload size is limited. The data that comes from global offices probably exceeds the allowed payload size for Amazon Kinesis, right? So that's the problem that we also have. So what are the concerns with this example? One concern is the Amazon CloudFront is compatible with this use case, right? But is that not cache the following operations? Right? So Amazon CloudFront it's compatible with this, right? But Amazon CloudFront does not cache the post, the put, the patch, the delete, or the options URL methods, right? It doesn't cache that. And that's very important because Amazon CloudFront works with caching, right? Continue. So generation 3, right? In this case, the payload on each report is not very large. Kinesis provides a speed that you want for processing the data, okay? So in this case, the payload is not big, and Amazon Kinesis can work with that, right? So we have a kind of Kinesis data stream coming from this client and this client in this office, right? And then Kinesis streams right here, and then it goes to the Kinesis and the application, right? It puts the data in Amazon Redshift, right? and then it uses QuickSight to visualize the data, right? So this is the way it works. Amazon pays real well for visualization of data. So a while ago, they had like a project where APA partners were to create business intelligence visualizations in QuickSight, and Amazon paid good money for that because it was the goal of the project was to reuse those charts for customers in the future. So they require of the partners to create QuickSight's visuals, and they pay them for that so that they could use them in the future with other projects. Okay. So we have here an application backend example, mobile gaming, right? So mobile games, how many of you guys play games?
Me.
Okay, I thought that because young people play a lot of games. Usually
Yeah.
you're only
That's too
17,
stressful for me.
you're only 17, Gabriel, right?
Yeah. Yeah.
Yeah. I was planning on buying a VR game, but I don't know how good that is.
Oh, that's really good. It's really cool.
Yeah.
It's definitely an experience you have to experience at least once in your lifetime. It's really freaking cool.
Yeah, you don't want to
It's
go.
it's expensive too.
No.
Yeah, Brian said it's expensive. It's pretty expensive, but I mean, if you get a good deal on it, it's worth it. Plus, it's not something that's coming out all the time, so you're gonna keep it for a while.
Does it mess up with your brain?
Does it mess up
Yeah,
your brain?
well,
No, I don't think so.
you know what? That's what I'm working on. And
I mean, it doesn't.
You don't want to go over 5 minutes. It will really cross your eyes.
What VR?
Yeah.
No, I
If
don't
you
think
have
so.
problems with spatial connection with your eyes.
Oh, like to judge like a distance? Is that what you mean?
Yeah.
Well, I mean, you gotta use it in like a safe environment. Obviously, have room. Like you gotta have room to walk around if you're gonna doing something to walk around in. Um, but as long as you take the parameters and you're like, yeah, you might get motion sickness. But honestly, I've tried it. And it's not that bad. I didn't get any of that.
It's not motion. Well, motion sicker is one of them, but the other one is it creates what is called tunnel vision.
Uh,
On some people where you actually get to lose depth. So if you do it, it's fun, but do it for short periods of time.
I mean, I've never had any of that. I guess I'm guessing
But
that's like,
you're probably very young.
yeah.
It doesn't bother you.
Yeah, that might be probably why. But I mean, from my experience, it's pretty freaking cool, and it's definitely something you should at least try once, because
Yeah.
it's just something surreal. It's like it kind of messes with your brain in the sense that like it's not real, but you're like looking at it, but it's not really there.
You
It's,
feel
it's
like,
pretty.
well, if the images are good,
Yeah, no, if
Yeah.
you have
you
good
will
quality
feel.
like VR, like if you're watching like a high quality YouTube video in VR, it's pretty freaking cool.
Yeah.
And
I
now,
have had the experience where I'm in a mountain up in Machu Picchu, and when I look down, you're actually seeing the edge of the mountain, and you're on the edge. You're on a ledge. You're on the edge,
Yeah.
and you feel like you're looking down in the mountain. It's very scary.
Mhm.
yeah, and now PlayStation 5 is coming.
Yeah, I saw that. It looks modern. It looks I think they did a good design. I think they got a good job designing it. It definitely looks like it belongs in 2020.
Yeah, it's a little pricey as
Frankly,
well.
I like our augmented reality better. It's
Mm.
kind of like a mix of both.
Yeah. It's kind of like what Pokemon did back in the day with Pokemon Go, where you
Uh-huh.
could have the Pokemon like the app will use your camera, and
Uh-huh.
you can have the Pokemon like appear and whatever the camera's pointing at.
Yeah,
Yeah.
it's just geolocation.
Yeah, and
So
geolocation and all that.
It's a
Jazz.
little pricey, huh?
Yeah. What,
you
the
mean
VR?
augmented reality? No,
What the
you
No,
can
no,
use it.
no,
Depends on your cell phone. You can use your cell phone for it.
no, I'm talking about VR.
No,
Oh, VR, it
depends.
depends.
They sell the accessories separately from the console, and it's like $800.
Oh, I mean, I didn't know. Wait, no, I
Oh,
mean, VR isn't a console. I mean, VR is like a headset that you connect to your PC, or depending on what you use. I mean, that's what I was just gonna
No,
say.
VR
no.
now?
On the
There's
lowest level, you can actually have VR, and it will cost you $10 in
yeah, yeah.
addition to your cell phone.
Yeah,
Yeah, but
there's Samsung VR and Google has a Google Box thing. It's like a cardboard box that you just assemble yourself, and I think it's pretty cheap, and you just put your phone in, and yeah, it's pretty cheap. But if
but
you
it,
want like real VR with like controllers that you have like two controllers in each hand, and you're like and you can like play games with, and like like there's games where you can like archery games and like sword games and like just all types of games in VR. And that type of VR, that level of VR is a little bit more pricey. Yeah, like $1,000 around there. That's a pretty
yeah,
pricey.
yeah.
But you need a heavy duty PC for that too if you're gonna be connecting it to your PC and all that. But
You need
I mean,
a
there's all sorts of different price ranges.
Yeah. So, mobile games, mobile app revenue is projected to grow continuously.
Hmm.
It's growing, 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 right? So these are some of the mobile backend technologies examples: HTTP based, external social APIs, safe state, database, static data store, mobile push, analytics. So third party technologies. So a few mobile game customers that use AWS include, I'm gonna read them for you guys. I don't know if you know them. I'm not quite familiar with gaming stuff or companies because I don't, I saw my first game when I was like 20 something, 26, 27. In Cuba, my generation, we didn't have any games or cell phones. I had my first cell phone when I was 31. So difficult times, right? So I don't know if you know Supercell. That it offers
Oh
heyday,
yeah,
heyday and
Supercell.
Clash of Clans.
Yeah, yeah. Supercell is the people that do Clash of
So
Clans.
they use AWS. So Half Brick, which offers Fruit Ninja,
Mm-hmm.
Wooga, which offers Diamond Dash and Pocket Village,
Okay.
Ubisoft, which used AWS to launch 10 social games in 18 months, Sega, which
Wow.
migrated forums and some game servers to AWS and reported a 50% savings in server costs,
I didn't know Sega was doing that.
and Fun Plus Game, a successful Facebook game company that began without physical servers but quickly moved to AWS to gain agility and reduce costs. Guys, there's so many companies that use AWS. So many companies. The list is
67%
Yeah,
of the
I
market.
recently
endless.
not recently, I saw it a while ago, but I watched a video on this YouTube channel. It's called Linus Tech Tips, and they made a video about AWS, and they titled it. I find it funny how they titled it. They were like, and it was something along the lines of, the company that like runs the internet,
Really?
because so many companies use AWS, they might as well just run the internet.
Mm-hmm.
HuffPost
Mm-mm.
and um, media's advertising, news. There's a lot of news companies that use AWS.
Mm-hmm. Even IBM in their courses for practitioner, they mention they mention the companies that move to AWS, but they don't mention AWS. AWS is a competitor, right?
Yeah.
Yes,
They
it is
teach,
big time. They're trying to get, yeah. They had a problem the other day though.
yeah, they teach students to pass the practitioner exam, but they talk about Netflix, right? They talk about Netflix. Next, they move to the cloud, but they don't mention that Netflix was the first one to go all in the cloud with AWS. They don't mention that, and they don't mention that Netflix is so successful today because of AWS. They don't mention that. They just mention that they're using the cloud, which is a general term, for Google, for Azure, for AWS, for IBM, for Alibaba, all of those guys, right? Because the cloud doesn't belong to anyone. The cloud is the cloud, right? Everybody uses the cloud. But cloud providers, AWS is the leading one. It's number one. It's always been, and I'm sure it will always be, because it's the pioneer. I created something, right? I created something, and then the other ones are my copy. You know, they're getting it from me. If you study Microsoft Azure, the concept is the same, exactly the same, different names, different terminology, the same thing. IBM uses NoSQL, and they use something called Cloudant. The Cloudant. That's the NoSQL database for them, which is DynamoDB for AWS, right? Azure uses a Cosmos DB, which is the same as DynamoDB. It's just a copy, but the concept is the same, different terminology. And if AWS was the first one, I created something. If I create something, and there's a bunch of guys after me creating something similar, they got it from me. I was the one that created it. They may transform it. They may change a little bit, but the concept, where did they get it from? I mean, you can transform something, but the original concept is mine, right? So I'm a little biased. I'm gonna continue. I love AWS. So mobile game backends are becoming more and more like the backends of web applications. For example, gaming backends use APIs to provide data and functionality. Guys, do you know what API is? No? Okay, let me show you a little API that I created. Okay. Let me show you a little API that I created. So if I come here,
something interface.
if I come here to localhost, well, I created something. This is something that I created yesterday using JavaScript and what? Oh, wait. I have to, wait. 1 moment. I have to run the server. Server is down. Okay. Let me see if I can find this guy here. I think I called it practice or something. Express? Yes, Express. Express? No, Express, no. Let me see real quick. No. All right. Server Express, JS. I'm just right here. JS. Okay. I'm going to open JS. Open. Oh, don't tell me that it froze now.
Yes, it's frozen.
I see my cursor. Other times I cannot see my, oh my God, it froze. All right, guys, let me stop this and restart my computer. I don't know why this is happening. I'll be here in a minute. In the meantime, you can talk there and whatever you want to do. I'll be back. Hey guys, I'm back.
We're here.
Yeah.
Guys, I found a graphic user interface for Ubuntu. I didn't know there was one.
Ubuntu.
Ubuntu.
Nice. So guys, I see, can you see my screen now? All right. This is an API that I created using Express to create a server and HTML, right? So you create a server here, you know, with some controllers, some classes, things like that, okay? And create a schema in MongoDB, right? To make the data persistent. So if I run the server here, I just put npm run def. So now my server is running. It's running on port 5000 and the database is connected successfully. All right, now if I come here to localhost, right, 5000.
I'm sorry, what is it that we're doing?
Huh? No, I'm just showing you what an API is.
Okay.
Right,
So,
it's an API that I created. It's like a destination that contains the data.
okay.
So I created this API. When I go to the server was started, it's an Express server. Just a server for JavaScript. So I created this form, right? And I put my information here. Let's put Dunieski. Let's say here, Julia Martinez. And then say Julia Martinez at AOL.com. Doesn't matter. Thread 4, Southwest, 56, Street, Apartamento, 103. The state, I can choose here, Florida, city, Miami, 23174. Example. Submit it, pun. And then the information is there, right? Now, if I put this, because I created an endpoint. If I come here to the server, I created an endpoint for users is right here in the controller in the routes. It's right here, users. So I have the base URL, which is localhost column 5000/users. It's gonna give me all the users that I have in the database. So if I do this, pun, all the users that I have in the database. So I have this that has a particular ID. This is what I don't show anybody, right? This ID here. This is my ID, right? But this is JSON. I'm just returning something for me to see. This is local, right? But if I have something that is global, I don't show this guy to anybody, right? And I don't show this only to myself, right? If I go to Atlas, which is MongoDB, right? And I log in, right? Oh, this is not Gmail. It's AOL. Okay. So now, if I log in, it should happen now. If I come here to collections, I'm gonna see that I have a collection called users, and then I have all the users there. Of course, if I try to input the same information, I will get an error that would tell me the user already exists. Okay. So if I come here and I say Julia again, boom, user already exists, please log in. Okay. So I have the collection here, users, and I have the 3 users here. So this is an API that's connected to HTML, and at the same time is connected to the database. It's like a full stack application, similar. Okay. Okay. That's an API. This is an API. Okay. Whatever is in the back end, where there's a destination that brings up some information. For example, if I put users here, this is getting the information from the API, right? The same happens with IMDb. You know IMDb? IMDb, Internet Movie Database. These guys, they have an API. That's why many companies, they have information about movies, because they make an API call from their application to the API here, and they can grab all the information about a movie. If you put, for example, here, Just Mercy, which I recommend strongly, very good movie. Okay, I recommend it. It's in Prime.
Yeah, I saw it. It's pretty good.
You saw it? Super
Yeah,
good.
very, very good. Actually, Clooney, the actor.
Just Clooney, yeah.
Yeah, he gave him $500,000 for his cost
Wow.
to Brian Stevenson.
This is Jamie Foxx, and this guy is a
It's
very
an amazing movie. Yeah, very good.
Michael B. Jordan. Okay, so whatever you have here, if you have the API information, you can bring all this information, the year that it was released, if it is PG-13, the length of the movie, biography, cream, if the genre, whatever, the same as we have here in localhost, same information, right? It will come in this format, which is JSON, right? Key value, JSON format. All right. Has any of you done any programming? No one? No? Yes? Maybe? Perhaps? All right, so we were saying that HTTP analytics, now we do the next one. So games, we think in terms of APIs, right? We get the request to retrieve the data about friends and leaderboards. We get it. This is an HTML method, HTTP method. We can get HTTP plus JSON, right? You know that HTTP stands for Hypertext Transfer Protocol, and JSON stands for JavaScript Object Notation, right? It's an object. An object has a key and a value, right? Like this, key and value. That's JSON, right? It's similar to YAML. YAML is how you write. You use JSON and YAML for confirmation templates, okay? But this is more complex than YAML. YAML, we don't need this curly braces or anything, okay? Or this, we don't need the square brackets either, right? And we use the square brackets because we have more than one. We have an array of objects. This is an object, and this is an object, and this is an object, okay? So we have multiplayer servers. We have binary assets. When you have binary assets, you're talking about pictures and images and all that, right? And game analytics. So we have here, the standby here. Don't forget that this is synchronous. The replication here is synchronous. And this AC2 instances, these ones are using this master database, and these ones are using too. Okay. And then we have the last load balancer here. We have mobile devices here, and they're also using CloudFront to come straight and use and get information from the Amazon S3. Remember, CloudFront uses one of the origins. It can be an EC2 instance, but it can also be an Amazon S3 bucket, right? So we can improve the game, right? So the information can be improved here. So we're going to review some examples of how to use the data analysis to gain insight from sentiment analysis and player behavior. Right? So to get insight into how your application is perceived, it can be helpful to collect data about the behaviors of your users. This means ingesting and processing streams of data as your application is being used, and then performing analysis on that data to gain insights from it. For example, you might want to know if users are enjoying the game, if they are engaged, or whether they like or dislike any new content, right? So understand why they're stuck on a level, bored, or have abandoned the game. So you can analyze the player's behavior to include hours played per day or week, the number of sessions per day, their level progression, and whether they invite or refer friends. You could also analyze the response to mobile push and how much money your users spend per week. So these are metrics to understand if the game is being, liked or not, right? So at data analytics for gaming, we have batch processing examples and we have real-time processing examples. So downloadable content is additional content for a video game that is distributed through the internet by the game's official publisher or one third-party content producer. It can be of several types, ranging from aesthetic outfit changes to a new extensive storyline that is similar to an expansion pack. So some examples of batch processing include: what game models do people like best? How many people have downloaded? Where do most player characters die? And how many daily players are there on average? So do you know that if people like games, they talk to friends and they play with friends, right? Like I say here, this is one of the ways that you can, know if people like the game or not, because they invite or refer, right? Other people. Okay. So in real-time processing examples, what game models are people playing now? So this is now, right? This is more like a general thing. The batch, remember, works with cold data. It's data that already stored, and then you analyze it, right? But this guy is now. How many people are playing now? Okay. Are more or fewer people downloading today? This is all about the now, the today. Are player characters dying in the same places or different places? And how many people are playing today? Is there any variance? Okay. It's using, adverse of time for now. It's using present continuous, right? It's all about now because it's in real time, right? Which is the advantage of real-time processing, in this case, Kinesis, over batch, which is another service for AWS. So we have here data analytics for gaming, right? This is more for gaming people more than anything, but you should understand the high level, right? So this example, what it does is shows a reference architecture, some of the cases for data analytics in the gaming, architecture. So use cases for data analytics in gaming include tracking player performance to keep games balanced and fair, tracking game performance metrics by geography or region for online games that have a global player base, tracking sales performance of items sold in game. People, when they play games, they also buy things like access to this, like other, accessories that or lives or guns, weapons that they can buy while they're playing, right? Tracking performance of online advertisements served in game. There are games that have announcements and advertisements, ads. Accelerating the delivery of the metrics that are described above to near real time. Retrieving continual in-game metrics on user engagement. Accessing real-time analytics or user engagements in the game. And receiving optimized predictions of when, of where to sell in-game purchases. This is amazing. this service gives you the capability of knowing when a customer can buy something, a specific point in the game when they will be willing to buy something. So this data analytics, what it does is it improves the performance in all respects in the game, in gaming architectures. So now there's some business benefits for using data analytics in gaming. For example, it reduces the operational burden of your developers, right? They don't have to analyze anything manually, right? Scaling your data analytics to match highly variable gaming loads without overpaying for spare capacity and experiencing increased time to results when usage is up, right? For example, trying more experiments with data experiments and finding new and game-changing metrics and analysis. Deliver continuous or real-time game insight data for hundreds of game servers. So basically, guys, people that create these apps, they can see real-time what's going on when people are playing. All right, that's when Kinesis comes in. All the help they can provide. For example, this case study for Supercell, which is a company that sells games, right? So Supercell, there's a analytics pipeline for Clash of Clans. That's one of the games, right? So a little history here. It's a gaming company that is based in Finland, and it was founded in 2010 by 6 game industry veterans. It's one of the fastest growing social game developers in the world. With a staff of just over 100 employees, Supercell has 3 games. Heyday, which is a social farming game, Clash of Clans, which is a social resource management game with strategic combat, and Boom Beach, which is a combat strategy game. These games attract tens of millions of players on iOS and Android devices every single day, right? So as an example, let's discuss Clash of Clans. Data is loaded into Amazon Redshift for business intelligence tasks. And the data is also moved into Amazon S3 for long-term archiving, right? That's Glacier. The team can restore the vaults from Amazon Glacier if they need to perform tasks such as recovering data, loading retrospective information into a new data warehouse instance, or augmenting their reports with data that was not originally available. So Supercell uses Amazon Kinesis with Amazon EC2, Amazon S3, Amazon Glacier, and Amazon Redshift to gain a complete view of how their customers are playing their games in real time. These AWS services also provide resources for analytics, especially Redshift, right? The team can dive into player data to answer specific questions, such as who are the high scorers, which area of the game world are most popular, or how the most recent updates are performing. There's another one. This is a guy. This is a guy from Supercell. Sami Lihariu said, he's the service lead at Supercell. He said, we are using Amazon Kinesis for real-time delivery of gaming side data sent by hundreds of our game engine servers. Amazon Kinesis also offloads a lot of developer burden in building a real-time streaming data ingestion platform and enables Supercell to focus on delivering games that delight players worldwide. So is AWS helpful when it comes to performance? Yes, it is. It's super good, right? And nothing is perfect, but I believe that the number of customers that are not happy with AWS is very low. I believe that. So transcoding and serving video files, and when we talk about this guy, we have the transcoder, which is the one that changes the format of the video, right? So transcoding video files challenging to set up. It's a little challenging. It's difficult to choose the right transcoding settings. It's complicated to build a system that performs well. Difficult to adapt. This is we're talking about these actions, right? The transcoding of video files. The amount of content can scale up quickly. Output formats and device types change frequently. The cost building for peak is uneconomical. Storage and delivery costs on a large scale can be prohibitive. So now comes AWS to save money, to save the day, right? So I know that some of you know about elastic transcoder. Can someone give me a definition of elastic transcoder? You still here, guys, or you left?
We're here.
Elastic
Still here.
transcoder allows you to change the format of your digital media into another format. So an MP4 to a what's the other one? I keep forgetting.
MP3.
MP3 for audio. So MP4 to MOV for iPads, for example.
Yes. So Amazon Elastic Transcoder is a highly scalable and cost-effective way for developers and businesses to convert or transcode video files from their sources format into versions that will play on devices like smartphones, tablets, and personal computers. So you can use Elastic Transcoder to convert files from different media formats into H.264, VP9, VP8, AAC, MP4, and MPEG- files at different resolutions, bitrates, and frame rates. You can also set up transcoding pipelines to transcode files in parallel. Okay.
This is what enables Netflix to run it on a cell phone, on a computer, on a smart TV, on an iPad, or on an iPhone, whatever. It doesn't matter.
Yes. So any customer with media assets that are stored in Amazon S3 can use Elastic Transcoder. Examples include developers who create applications or websites and publish user-generated content, enterprises and educational establishments that convert training and communication videos, and content owners and broadcasters that need to convert media assets into web-friendly formats.
Now, this will be in front of CloudFront, right? So, if you're doing distribution through CloudFront.
CloudFront is a content delivery.
So you will have this behind CloudFront. And CloudFront will deliver it in the right format of whatever device you're using.
Right. CloudFront delivered the converted format already.
Mm-hmm.
Okay. So another one that we didn't mention is AVI. That's another format for video. AVI.
Yes.
Which is this? This is the. What is this? This is the VLC player. Do you want to see this cone here? This cone, that's the VLC player. Okay, these are media source asset. Is in Amazon S3. Then you use a transcoder to change the format. You put it in another S3 bucket. This is the input bucket, and this is the output bucket, and then the content is delivered, right, in a different format. Right, that's the destination asset, and this is the source asset. All right, so it's very simple. It's very straightforward. All right, guys, this is the end of this lecture. It's been 4 hours. Wow, long time. Well, actually, not 4 hours, 3 hours. So, guys, today was the last class of the last content. I mean, the last PowerPoint. Let me stop this. This is not relevant to